Okay, in this video I go over homework 8. Homework 8, there was a data envelopment analysis problem where we had 3 airline companies. I think I listed them as A, B, and C, but for this to work using the VBA code, I went ahead and converted them to 1, 2, and 3. But we had 3 airline companies. We had 3 inputs, so what I did is I inserted a column between my 2 values, and then I took the homework data and did a copy paste special and did a transpose. So when I pasted special, like when I took the data and I copied it from somewhere else and did a paste special, I transposed it. That way when it was in rows I could convert it to columns. That's what I did. And that made it so I didn't have to do one at a time. Same thing on the outputs. We had 3 originally, and so I inserted a column. I inserted a column in between, not on the end, and then did another copy paste special transpose. So these become the inputs. These are my outputs, and remember how this is set up is on the outputs positive. The bigger it is, the better. So when you have numbers that the bigger it's worse, you have to put a negative in front of them. And if you do that, then you have to write a formula or create another decision variable. So these are my decision variables, these 3 on the inputs, these 4 on the outputs. Your input cost function, if you insert a column is those. You copy that down for all 3, and then your output is those. Copy that down for all 3 airlines. Then you use some VLOOKUPs that if you pick the first one, then your input cost, it VLOOKUPs and it looks this up. It looks up this number. It looks up the output, doing another VLOOKUP to get this value if it's the first one. And then your solver, which you already had, we're trying to take that, maximize the output by changing these cells, and then the input costs have to be greater than the output cost, and the efficiency, the input cost has to be exactly equal to 1 for the selected one. So when you do the first one and you do this, you get 72, which means it's not an efficient airline. That means that there's another airline that's better than it, that's doing more with less. You do it with the second one and run it again, and it's even less efficient. And then you do it with the third one, and it is 100%. So we're not saying airline 3 is the best, but it's saying it's efficient. So the other 2 ought to look at those and see what are they doing when they have a smaller labor pool, fewer flights, yet they seem to be doing better on these performance metrics on these sides. So what are they doing? This is who you would benchmark against. And you could write, again, the VBA code was already set up, so if you wanted to run that, it could run all 3 of those and get those numbers fast. This is very powerful if you had 100 airline companies and you wanted to run through all of those quickly. You wouldn't have to run solver 3 times. Okay, for the simulation problem, all we did was extend the problem that we had before. The only thing that changed from the problem that we did in class is that you had to run it for 50 trials instead of 40, and the unit price changed. Now, you're going to do this and you're going to be able to get a confidence interval on the profit using these formulas that I've already given to you. Just for grins, if you've been in my ops class, you know that there's a closed form equation for this, because what you can do is calculate the cost of not having enough. So let's say that I order 200 and I have more than that. The demand is more than 200. Well, then I'm out of pocket every $42 for every one I'm short. So that's my cost of not having enough. And my cost of having too much, so if I have too many, of these, then what is the cost to that? The cost of that is the unit cost minus my salvage. And then from those, you can calculate an optimal service level by just taking CU over the sum of CU and CO. So what it's telling me is that the service level I should try to achieve is about 89%. And given a normal distribution centered at 200 with a standard deviation of 25, if you use the norm INV function, it'll tell you that you ought to have an order quantity. You put in your service level of 89%, then your mean and standard deviation, and it gives you a target service level of 231 units. So that's the best answer from a closed form equation. But plenty of problems you don't have a closed form equation. So I ran it for 200, 205, 210, and I don't think I emphasized this in the videos, but when I did this, I pulled the random number from the 200 worksheet. So I didn't get another set of random numbers. I wanted it to be as close to an apples to apples. So this demand is identical to this demand, which is identical to any of these. They all stay the same. The only thing that changes is the order quantity. Nothing else changes. So when I look at the plot of these, again, this is the confidence intervals of my numbers, and then I'm just running it over and over. You can see we're kind of having this effect, and I should have probably run longer than 250, but you're going to see this thing start going down as you get a larger order quantity. And it looks like probably what you should do is something in this world. If I had to stop right now, I would say, well, it's probably between 220 and 250. Those are all about the same numbers. These are lower. Now there's less variability, so if you're someone who's risk averse, maybe this is more important to you than the variability. This is covering about about $400, and this is covering 1, 2, 3, almost 4. The variability is, over $1,000. So if you're wanting less uncertainty, you may take the smaller number. But generally, the further you go this way, these numbers will drop down, but the variability will even get wider. So again, somewhere in there is what you would do based on understanding from the simulation output, which includes the 230 that we solved for in its entirety. Okay, that's the solution. Thanks.